These are your molarity questions in your notes. Again, molarity is your moles of solute per liters of solution. So we say it's a 1 molar solution, meaning there's 1 mole of solute, the dissolved substance, per liter of solution. That's per liter solution, not per liter of water, but per liter of solution with the solute in it. So 22b, starting with number 22b, you have an IV solution that's 5.1 grams of glucose dissolved in 100.5 milliliters. So first thing we need to do is get the grams of glucose into moles. So if we say we have 5.10 grams of glucose, we're going to turn that into moles. That's our solute, so we're getting that into moles. Grams of glucose is 180 per mole. So I'll get my moles, that is 0.0283 moles of glucose. There's our moles. We need to divide that by the total number of liters. Well, it says we have 100.5 milliliters. There's 1,000 milliliters in a liter, so we need to divide this by 1,000, which gives us, that'd be 3 decimal places back, so 0.1005 liters. So put this over 0.1005 liters, divide the two, and we get our moles per liter, which is 0.28. You can just put a big M. That means molar solution. In other words, there's 0.28 moles of solute, glucose, for every 1 liter of solution. So if you had 2 liters of this solution, it'd be double the number of moles, it'd be 0.56. If you had a half a liter solution, you'd have 0.14 total moles in there. 22C, I want you to figure out the molarity. It tells you your grams again, so pretty much the same type of problem. I'll do this one fairly quickly. You have 1.55 grams of potassium bromide. Turn into moles, it's 119 grams per mole. I'm just going to go ahead and just put the number of liters of solution. It is 1.6 liters of solution. So if you look here, my labels are going to be moles over liters. Moles over liters. So I have nothing up here, but I'm just going to divide by the number of liters. And I end up with a 0.0081 molar solution. It's a pretty low molarity. 23 is asking how you would make a solution. So I go out to the lab, I'm sure how you guys do, and say, hey, make a 1 molar solution of sodium chloride. Okay. And maybe I say to make 20 milliliters of it. So you have to know how many grams to put in and how much water to put in. So 23A there wants to know how many grams of calcium chloride would you put in 1 liter of a 0.1 molar solution. So I'm going to start off with my liters, okay, and say that 1 liter. And I'm going to write my molarity like this. So 0.1 molar means 0.1 moles of calcium chloride per 1 liter of solution. So I can put that in here. I could flip it around. It could be written this way. I'm just going to say for every 1 liter of solution, there's 0.1 moles of calcium chloride. It wants to know grams, turn that into grams. Every mole of calcium chloride is 111 grams. So you get about 11.1 grams of calcium chloride. Again, I can use my molarity. I can flip it around. I can keep it this way. I can use it whichever way I need to use, but I need to know that molarity means moles per liter. That's the biggest thing to know. Molarity is moles per liter. Next one in there, letter B. How many grams of sodium hydroxide are in 250 milliliters of solution? So first thing, 250 milliliters. To convert that into liters, move the decimal back 3 places, is 0.250 liters. So I'm going to start with that. So okay, we have 0.25 liters of solution. I'm going to put my molarity in here. Molarity is, it is a 3 molar solution. That means that for every 1 liter, there's 3 moles. For every 1 liter, there's 3 moles of the solute, which is NaOH. So liters and liters cancel. Get this into grams, and for sodium hydroxide, it is every mole is 40 grams for sodium hydroxide. And you end up with an answer of about 30 grams of NaOH. So I have to dissolve 30 grams of sodium hydroxide in 250 milliliters of water to make a 3 molar solution. The solution would then be 3 molar at that point in time. Letter C there is basically the same thing. You have 500 milliliters, which would be 0.5 liters. Put your molarity in. The molarity is 0.2 molar. So for every 1 liter, there's 0.2 moles. And then I can say that every mole in its moles of calcium chloride is 111 grams. And I get 11.1. Okay, so those are similar problems. So I went through the second one pretty fast. So start with my liters. Again, this is the molarity. If I started with moles, I would put moles in the bottom, put liters up on top. I don't have a problem like that on here, but I will eventually have one where we have to do that. Actually, I'm going to give you one right now like that. So let's say now that I give you, I want to know how many liters of solution it would take to get, I want to get 5 moles. We'll just keep using calcium chloride. I want to get 5 moles of calcium chloride. I want to know how many liters of solution it would take if I give you a 1.3 molar solution. So I'm going to say, okay, I want to get 5 moles of calcium chloride. I can put my molarity in like this. I can say that for every 1.3 moles on the bottom of calcium chloride, there is 1 liter of solution. And I'm done. So if I wanted to get 5 moles, I would take 5 divided by 1.3, which is about close to 4. I would take about 4 liters of solution to get 5 moles out of a concentrated solution that's 1.3 molar. Number 24, I'll put on a different video of dilution problems. They're a little bit tougher.